Hello guys and welcome back. So let's see if we can finish up this video with the movement in first person using in cover. So I just noticed that I made a little mistake here. So when we are in first person and moving up against the wall in cover and I press left, I just noticed when I was looking down at his feet is moving the wrong way. So when I zoom out, he's actually moving the wrong way. But in third person, he's moving the correct way. So I was wondering why that was happening, and I noticed that I set the direction. I invert the local axis value over here, but I don't put that into the movement direction. So I actually need to switch these two. So I'm inside the handle right movement. This one we called from the handle move right. So I'm inside this guy here. So I want to take that part that handles the false part and cut that out. And I want to move all this stuff here over here and connect that up with the branch, and then I want to paste. Whoops, that's not what I want to do. I want to paste this stuff here, and well, let's just put it here. This is an okay place to put it. So I'll connect this one up, and then connect this one like this. So now we have the correct local axis value, so we multiply that sign of this correctly into the movement direction. So let's test this out. So I press right and I press left, he moves correctly and does the turning correctly. And in first person, I press left now, he moves correctly, and right correctly. So it looks better now. Well, so let's continue addressing the problem with the head, because still the head is positioned wrong, I think. And we do this by going into the place where we have the camera zoom handled. That's here. That's, if you remember from the previous videos, this big guy, tons of stuff going on. But this last stuff that we did was to set this local yaw limit to -70 to handle the case where we are in cover. So we have at the end here this stuff happening. So what we want to do is to adjust the first person camera according to actually the direction we are moving in. And we can set local, no, it's called relative location for the first person camera. So we can plug this in at the end here. And right now, if we take a look at what we have for the first person camera, we have 10, 8 and -10. So if we assume 10, 8 up, 8 and -10, then let's say we wanted to zero out the X first and see what that changes. So let's come in here, and now we are a little bit lower, and that's maybe a little bit too much, so let's go with 4 maybe. Let's move the camera a bit forward, so 15 maybe. So that's gonna put him like here. I kind of like the way it looks from this angle, but problem is when I move to the right, it's not gonna look good at all. So let's concentrate on the left movement first, because this I think looks pretty good. It's kind of a bummer that I can see the head here, so I will maybe I think I'm gonna do something like change this to something like 110, so we can't look that much behind. So something like this. It's almost good, I think. Something we can adjust a little bit. So now he can't look so much back, but I wanted him to look to be able to look a little bit further forward. So let's also introduce a new variable. Let's call this a local yaw offset, and make this a float. So to our local yaw limit in the direction we are moving, we want to add something to this so we can look further forward. So let's just to begin with add 50 degrees to the forward yaw limit. And this is starting to be quite messy, I see. I need to clean this up later, but let's just focus on what we have here. So that was actually the wrong one I added. It needs to be this one maybe. The minus one. Yep. Okay, so that also means that when we come to a corner, we can kind of peek. I think that's pretty cool. Hope fell off the wall. So we can do something like this, like move really close to the wall and almost see around the corner. Or maybe we actually need to add some more. 60 degrees. So up here. And okay. Well, it looks okay. And right now you can see we can't look so much behind us, but I think that's pretty good. If we move back again, we have this issue now with the camera position. So I guess one way of fixing this is to say, okay, if we are moving left in the left direction, then we will use this. And if we let's copy this and see how that works, just to see if I'm correct. So I have the values here. So if I make this negative, it should be looking good for the right movement. So get in here, and now it looks bad for the left movement. But if I move right, we can only look at a certain distance to the right, but too far to the other side. So this yaw limit needs to be negated. Okay. So move to the right, and now we can't look actually we can't look very far in any. Oh, okay. In that situation, we actually need to add it to the other one. What a bummer. Okay, so this one will need to be added. Okay, so this is going to be a bit complicated, I think, because now, depending on which direction we are moving, it needs to be added to one or the other. Okay, so let's go into first person and move to the right. So now I can't look very far to the left, but I can look a bit further to the right. And it looks good when I move to the right, and yeah, I'm in the right pose, so to speak. So okay, so what I need now is to find a way to know if I'm moving left or right. And we already have that information just inside the blueprint, because we handle that by looking at the movement direction. But since the movement direction, these are state machines, and we always jump to the left pose when we go into this pose, then we should always assume that we are in the left pose when we jump onto a wall. So let's do that. So inside the base character blueprint, we have that piece of code where we get into take cover, and we do this inside here, and this is where all the traces happen. And if we can take cover, then we say, okay, we are taking cover. So this boolean is saying if we are taking cover. So let's make a new variable for this. Let's call this current movement direction, and maybe this is a bad name for it, but let's just stick with that for now. I can always change that later. So what we want to set this to is to be, let's just work with 1 and minus 1, because it's kind of easy to work with. So if we, let's plug it in here. So let's set, for now, even though I would prefer to put this outside, but it's just also going to make a mess out there. So the current move direction, if we are taking cover, is going to be 1, which means to the left, and we will always set that. So, and also inside the handle, let's go into this, move right. So inside the handle, move right, where we set the local axis value. We want to also output this value, and I could just let's just set it inside here for now, but I would definitely recommend to output that value. No, let's do it. So from the return node here, let's drag out the local axis value, because this tells us if we are moving left or right. And let me think, because we need to get the we don't need the inverted value. We actually want the real. Okay, sorry about that. Let's not output that. Let's just work with the unmodified version. So what we will do is to say, okay, if we are in this standing cover and in first person, then we want to update this current movement direction according to the direction that we are moving. So and we only want to do this if it's either 1 or minus 1. If it's 0, we don't want to touch that value, because then it will just stay the value that it was when we left it. So Hope that made sense. So we want to check the value of the local axis value, because that reflects the current. Okay, this is a really bad name. Well, the direction that the controller is saying we are moving. So we check, are you different? Are you different from 0? Not this one. Okay, fat fingers, great. Are you different from 0? And if you are, let's just make the code here. If you are different from 0, then we want to take this value and plug it into the current movement direction. So we want to set this one equal to this one. And we don't want to plug anything into the false part, because yeah, as I said, we only want to do this in case we are making any movement. So this little piece of code we need to plug in between, well, it needs to be before we alter the local axis value. So this actually needs to go, we could just plug it in here in between this one and this one. So as you can tell, I haven't really tried this out. So for now, let's just do like this and then connect this one up, and then we can clean up the layout of this afterwards. So to test this out, we could go and go back to the camera zoom and say, okay, the easiest way to test this is to take these two here and ignore this one for now, just zero this one out. Remember, we had a good value of 60, and say, okay, depending on this current movement direction, get. So we want to say, okay, are you greater than 0? Then okay, let's move this a little bit. So let's make the branch here. So are you greater than 0? Then we want to go through this one, and maybe it's the other way around. Okay, I can never tell. Okay, and anyway, if it's false, then we take the other one, and in a way, we want to go through this one. So that came out pretty messy. Okay, but anyway, let's test this. So the difference is we have a difference on the C here only, but it should reposition the camera if I made this correct. So go into first person, and it looks like I messed it up. Or maybe I didn't, because now it actually does look okay. Something is coming in front of the camera when I turn. But as you can see now, in both left and right, the camera looks to be positioned somewhat, well, looks pretty okay. Now we can't peek around the corner anymore, but that's because I didn't, I zeroed out that addition. I think since this video became, as usual, a little bit longer than I expected, I will cut the video short here and then address the last issues in the next video. So I will also make a little bit of cleanup on this and show how that turned out in the end. Okay, so sorry for the mess, but anyway, see you in the next.